Educators heavily invest in student self-determination based on a specific premise. Giving students control over their learning directly improves their grades. Mammadov and Schroeder aggregated a massive dataset to test this. Their 2023 meta-analysis examined 213,612 students across heterogeneous educational environments. They started with 4,142 records and systematically stripped away the noise, distilling the literature down to 153 high-quality studies and 378 effect sizes. This data visualization maps 378 effect sizes into a single weighted mean. The baseline shows a positive correlation of 0.32 between autonomy support and generalized learning outcomes. But isolating academic performance, the direct correlation collapses to a statistically insignificant 0.03. To understand the collapse, we have to look at how self-determination theory defines autonomy support. It requires providing a rationale, offering meaningful choice, and ensuring relevance. Teachers and parents use these practices to foster a student's internal locus of causality. This operates in direct contrast to using rewards or strict deadlines to force compliance. A broad average of 0.32 obscures how these localized mechanisms actually function. Meta-regression is required to locate exactly where the intervention is succeeding and failing. The researchers used robust variance estimation to handle the within-cluster heterogeneity across the 179 independent samples in the study. We have to systematically deconstruct these statistical moderators to track where the autonomy mechanism is operating. The data clearly shows it is not operating on the final grade. The first variable to isolate is the source of the support. The literature frequently assumes that autonomy provided at home and autonomy provided in the classroom yield similar results. These two probability distribution curves plot effect sizes based on the agent of support. Teachers act as the dominant functional agents, outpacing parents. Holding variables constant, teacher autonomy support operates at a 0.11 standard deviation superiority over parent support. The parent data is statistically fragile. When you trace the confidence interval for the parent-agent curve, the lower bound routinely crosses the zero effect threshold. The classroom microclimate overrides domestic autonomy support. Any functional intervention must be localized to the teacher's interaction style. Autonomy support does not act upon global academic success. It targets highly localized cognitive states. This bar chart plots specific row values for teacher autonomy support across dependent variables. The highest correlation is autonomous motivation at 0.41, where a student's internal drive shifts significantly. Mastery goals follow closely at 0.40 as students focus on developing competence. Behavioral engagement plots at 0.38, indicating observable persistence and active cognitive strategy use. The total collapse occurs at the final metric. Academic performance sits almost completely flat against the baseline at 0.03. Teacher autonomy support reliably alters internal motivation and behavioral persistence. It is a precise psychological tool that fails to translate directly into test scores. The meta-regression revealed an anomaly regarding demographic distribution within teacher-led autonomy support. This scatterplot maps the percentage of females on the x-axis against the row value for teacher autonomy support on the y-axis. The negative slope shows an inverse correlation. As the percentage of females in a sample increases, the efficacy of the autonomy support decreases. Classical gender role socialization theories previously hypothesized the opposite, suggesting females benefit more from affective, autonomy-supportive teacher-student relationships. The numbers contradict that framework. Regardless of demographic variance, the 0.03 coefficient for academic performance remains universally disconnected from the psychological benefits. To explain this, we have to establish psychometric proximity. Grades and test scores are heavily contaminated distal outputs. They reflect prior knowledge, external contingencies, and structural testing biases. Autonomy support cannot bypass these external mechanics. It requires an architectural bridge to properly influence the final distal outcome. We must reconstruct the learning sequence through a path analysis, rather than seeking direct correlation. The structural equation model begins here, at the origin point of the classroom environment. Teacher autonomy support. Testing for a direct intervention model yields this path to academic performance. The connection is a statistically insignificant 0.03. Autonomy support satisfies basic psychological needs, generating required proximal mediators. Solid pathways connect the classroom environment to autonomous motivation and behavioral engagement. The structural pathway completes when these intermediate states activate. Through prolonged behavioral engagement and intrinsic motivation, academic performance increases. Autonomy support lacks the structural capacity to improve performance on its own. It must first pass through the proximal mediators of motivation and engagement. This mediation model dictates strict parameters for instructional design and curriculum development. Implementing self-paced modules or student-selected reading, expecting to raise test scores, is an operational error. Autonomy interventions must be deployed exclusively to build and sustain the psychological engine of the learner. Autonomy support builds the engagement. The engagement does the academic work.